In the last class, we talked about the creation of a normalized database for data collection and management. You may remember several of the reasons for normalizing the database schema. The two main points were increasing the efficiency of the database and reducing the amount of data redundancy. Today we're going to talk about writing queries for a normalized database. When considering database design and performance, there are usually considerations between data collection and management versus data reporting for querying. Designers who are focused on data collection and management generally want to increase efficient collection, which includes data inserts and updates. Designers who are focused on data reporting want to increase the ability of the database to support fast queries and the ease of report operations. There are always trade-offs when making these decisions, and you may have to make your own determination based on the situation for a given project. Another likely scenario is that you may not be the one making the design decisions, but you have to deal with the design that is already in place when you start to create your queries. Here is the last figure from the previous presentation. Just to review, this is the database in third normal form that has also had two calculated data elements removed. If you remember, the original data was a single table, and each row had all of the information for an order of items. It was attractive from a reporting standpoint because all of the data is in a single row, and you can visually locate it if you understand the order and the data process. As you can see from looking at this figure, no single table will provide enough information to understand anything about an individual order. So what do we have to do to assemble an order from this type of data schema, a normalized schema? This screen shows an SQL select statement, which is needed to connect the data from all the tables. The database has 6 tables, and each of the tables are part of this query. Because table names need to be descriptive, they can be longer than we want when writing code. A common convention is to select a short abbreviation of 1, 2, or possibly 3 characters to symbolically represent each table. If you look at the slide, you will see this has been done for each of the 6 tables. The order table is represented by a single character O. The order item table is represented by 2 characters, OI. The item table, the single character I. The contact information table, CI. The order payment table, OP, and the payment type table, PT. It should be obvious that the abbreviations for the tables must be unique. The first line of the query selects all of the data from the order table. In this case, the asterisk symbol means select all of the columns in the table. If you wanted to select a certain number of columns manually, you could list them. You could also change the order here. They will come out in the order you list them, regardless of which order they are in the table. The next 6 lines of code specify what is called an inner join for a pair of tables. The first of these join statements connects the order item table to the order table, by linking the two key fields order ID from each table. The second join statement joins the item table to the order table using the primary and foreign key item number. As you look at each statement, you will see that the table abbreviation is connected to a variable name separated by a period. The table abbreviation tells you which tables are being joined. These 7 lines of code select the data and put it into temporary memory space. Additional code is needed to manipulate the data into a usable format. This may include additional select statements, if and where statements, and order by statements. You would then need some code to indicate what do you want to do with the data or subset of data you have created from your query. Generally, this will involve writing the selected data to a file. If you're creating a report, then you may need some additional formatting code. If you're creating a data set for analysis, you may be done at this point. This screen illustrates 2 situations that you would have to deal with as a data analyst. The first is when there are many-to-many relationships in the database schema. When 2 tables are in this kind of relationship, there is an intermediate table which tracks all of the unions between the 2 tables. This situation requires several where statements, which can be quite complex. So the number of many-to-many relationships you have will impact the type of queries you must write. The second case is when there are records in the database that have null or empty foreign keys. Anytime there is an empty foreign key, those records will not be returned by the query from the previous slide. This can happen because not all the entities need to be present all of the time, or because there's a data quality or a data integrity issue. In either case, you will usually find out by someone who is not happy with the report that there is missing data. And you're going to have to go back and adjust your query to make sure that it accounts for null or empty foreign keys. So there are trade-offs. To reconstruct the order in this example, you need 6 join statements. Depending on the size of the database, the number of rows, operations like table joins can take up a lot of available resources of a server, especially when there are a lot of filtering or ordering statements. This is why many data centers have a copy of the database, which is used for reporting, to prevent this kind of activity from impacting the daily operation of collecting and managing the data. Finally, in real life, you may find yourself in one of these situations. First, you may not be the creator of the database. In this case, you will have no ability to change the type or level of normalization. If the database is not well documented, you may not even know how normalized the database really is. Or perhaps you are the creator of the database. In this case, you have to live with what you've done. You may discover that your original design, which worked well early on, is not as flexible or agile in the data situation you now find yourself in. You may not be able to do anything about it just because of the amount of data that's already in there, or because there's no resources or time to change an active database. However, at least you will understand what you have. A final comment: regardless of the type of database that you're working with, you will almost always have to make a compromise between the data collection and data reporting. But you should remember, people often put more energy into the data collection and less thought into the data reporting side of the equation. Thank you.